Hello, ladies and gentlemen. You are welcome. You are welcome. Let's just see where we can get at least something a little bit clear. Where can we be a little bit more clearer? I think this side is a little bit, yeah, feel much better. There we go. Let's use this side. It's a little bit clearer. Yes, so last time we started looking, into the topic of momentum. So where we've been looking into momentum and impulse. And I gave you the definition. If you can go back to the previous video where we talked about that the momentum of an object, is simply a what? It is a product of mass and its velocity. That's what we said last time. But today, what we are going to do, we are going to look into what we call change in momentum. Now, in case you are saying, but so what do you mean by change in momentum? Well, I'm going to begin to explain to you something very, very important. When we are talking about momentum, we simply assume that you see this momentum is constant, So if you say that we are moving at 120 kilometers per hour in the northern direction, we simply assume that this speed is constant. It's not changing. There's no disturbance whatsoever, okay? But let us take note of this, guys. We cannot become rigid or static, where we deceive ourselves that momentum cannot change. There are different factors, that could lead to the change in momentum. For example, maybe you are moving on a smooth surface, everything was smooth. But suddenly you discover there are some rough patches, or potholes. You can't tell me that the speed is going to be constant. Or maybe you are moving, then you discover that in your direction, there can be traffic, maybe there is a police or just too much traffic, there are a lot of vehicles, and you decide, to apply your gear, to apply your brakes, then you slow down. So all that could lead to a change in momentum. So that is what we want to study together. What is the effect of the change, in momentum? What happens, in case maybe, as I said, you are moving at a certain, constant, velocity, maybe 20 kilometers per hour. Then suddenly you decide to slow down. So we want to look into that change. So I think by now you must begin to understand, especially, as a scientist, that whenever you talk about change, you are talking about delta, so there will be a delta, there will be a change. So let's now look into this topic and explain it, because I don't want, you go in exams, or maybe they have asked you some questions, then you are wondering, what do they mean, by the change in momentum? Let me read a few points. They said to you, the vector nature of velocity. Now, when they say the vector nature of velocity determine the vector nature of momentum, listen to this. The vector nature of velocity. Did you pick that? The vector nature. Why is that word vector important? It means momentum is a vector quantity. It gives you direction where we are going to. Is it upwards? Is it downwards? Are we going to the east, to the west, etc.? So the vector nature of velocity determines the nature of momentum, and the velocity and the momentum of object are always in the same direction. I like that. What does this mean? It simply means if your momentum is in the eastern direction, it simply means your velocity is also going to be in the eastern direction. So you cannot be having, momentum going to the south, then velocity to the north. No, they are always in the same direction. So take note of that part. So the vector nature, will be able to determine. So meaning there is some form of relationship between momentum and its, vector, so its velocity. So where are we going? Is it in the eastern direction? Then you need to find out at what velocity, 20 kilometers per hour. And as I said to you, there are certain factors that could make you to change, your speed, or to change your velocity. And by now, you need to know the difference between speed and velocity. Speed is a scalar quantity. It doesn't give you direction. It will just say 20 kilometers per hour. It will stop there. But when it is velocity, it will tell you 20 kilometers per hour to the south. So that's the difference. So one is a scalar quantity, the other is a vector quantity. When the mass, last time I was also mentioning issues of mass. So you need to begin to understand what do they mean by mass. 2 kg, 4 kg, 50 kg, etc. So when the mass and the velocity of an object, they remain constant. That's what I was telling you. So from the initial stage, we just assume that you see the mass and velocity is constant. So if we start with 20 kg, we simply say, okay, until the end of the journey, we are going to have 20 kg. But is that true? No. Things can change. How about if we decide to pack, we decide to put more loads on top? The kg is going to increase. Okay, we want to travel, from point A to point B, and you see, you find that the mass maybe of the vehicle is 750. But as you are traveling, you decide, to put some bags of cement. Now, bags of cement have got also their own masses. Have you now seen? So there will be now a change in momentum, because the one that you started with initially is not going to be the same. So when the mass and the velocity of an object, they remain constant, the momentum of the object will also remain constant. It also doesn't change. Why? Because it is constant. The mass of most objects remain constant throughout. For example, maybe the vehicle you are traveling in is at 750 kg. Most of the time, we don't normally put things, so it can be 750 kg. But velocity can easily change, because, you cannot just move at 120 kilometers per hour from Cape to Cairo. There will be obstacles along the way, isn't it? So think about maybe a jumbo jet. So you've started from an airport, and maybe you are at 2,500 tons, that one won't change, but the velocity will be changing. I hope somebody is understanding. So in most cases, the mass does not change. But did I say that mass is static? No. Mass can also change. You can decide to put, more stuff on. After you do that, you discover that your mass can change. Now, when the velocity of an object changes, did you pick what I said? When the velocity, so you are at 250 kg or 250 kilometers per hour, But what happens if the velocity is changed? Very simple. It simply means that momentum is also going to change. I told you that there is a relationship between momentum and velocity. So as long as the mass and the velocity, they remain constant, then momentum is also going to be constant. But in case we decide to change our velocity, it simply means your momentum, your final answer is also going to change. I hope you are picking those points and you are jotting them down. So when the velocity of an object remains constant, we said momentum will also remain constant. But when the velocity of an object changes, the momentum is also going to change. So the change in momentum is now going to be called delta P. Remember when we started, we mentioned that we use the symbol P for momentum, okay? So if there is no change in momentum, just put the letter P with an arrow. That is giving direction. Which direction are you heading to? Is it in the south? Is it in the north, etc.? But anytime velocity change from 20 kilometers per hour to 16 kilometers per hour, it's no longer just a P. It now become delta P with an arrow to indicate that it's a vector quantity. So I hope you are picking those points. So anytime there is a change in momentum, it simply means you're gonna put a delta. Delta indicates to me, it will indicate to an examiner, it will indicate to your educator that there is a change, you know. Delta simply means change in time, change in distance, change in speed, change in momentum, etc. So that's why the Greek, they decided to use the letter D for, delta. Let's use the word delta, not D. So take note of that. So there will be the change in momentum is the difference between the initial momentum and the final momentum. Did you pick what I just said? We said, what is the change of momentum? Then we said that the change of momentum, it is the difference. You guys, by now you need to know this. Last time we talked about product, which is the multiplication. We talked about sum, which is addition. Difference means what? Subtraction. So you're going to subtract your initial momentum that you started with, that 20 kilometers per hour. Then there is a change in velocity to 16 kilometers per hour. So what is the change in momentum? 20 kilometers per hour minus 16 kilometers per hour. So the change in momentum is what? 4 kilometers per hour. Is that making sense? So that's how you go about the change in momentum. So change in momentum takes place when there is a change in velocity. So velocity from the initial stage, we can assume that it's just going to be constant throughout, 20 kilometers per hour, 20 kilometers per hour, 20 kilometers per hour. But we say, no, let us not deceive ourselves. Sometimes certain factors, phenomena can happen, which could lead to a slowdown or accelerating. So once there is that change, that's the one that we call the change in momentum. So the change in momentum is simply the difference between the initial momentum. What is initial momentum? The one that you started with. So they will tell you in the question paper, they will tell you the momentum that you started with, They will say 20 kg whatsoever, 70 kg whatsoever, 20 kilometers, etc. That's the initial. Then the final is the one that you end with. For example, you started with the 70, then you ended with the 50. What is the difference? 20. Are you now seeing that? So it is simply a difference between the initial momentum subtracted by the final momentum. That is the one that gives you the change in momentum. For example, you've got a car with a mass of 600 kg. So imagine you have got this vehicle and the mass, it is at 600 kg. Please don't constrict yourself. It doesn't mean that all the vehicles have got the same kg. They can put any kg, so that thing can change. So this is just an example. So there is a vehicle of 600 kg, which is traveling in the eastern direction along a straight horizontal road. So you see, This is a horizontal, and we assume that it's so smooth, everything is fine, etc. At a constant velocity, 20 kilometers per hour, everything is moving nicely. This vehicle is going to the eastern, direction, and it is at a constant velocity of 20, kilometers per hour. But suddenly, something take place. What happened? Suddenly, the driver decided to increase the velocity. I mean, you say, well, I'm moving too slow. Because, of course, 20 kilometers. In fact, instead of saying kilometers, let me use meters. 20 meters per second. Let me move from 20 meters to 24 meters per second. Have you now noticed there's a shift from 20 meters per second to 24 meters per second. And it continues in the original direction. Then they ask you to determine the change in momentum. So what could be the change in momentum of your vehicle? So you must just take note, the eastern direction will still be in the positive because you didn't make a detour, you didn't change your direction, you are still maintaining. So you go about with your initial momentum is equal to mass times the initial velocity, which was actually your 600, and your 20. It will give you, when you do your multiplication there, 12,000 kg per meter per second. I'm not having calculator. I hope I'm doing the proper calculations there. So when you follow through the formula, then you're going to see at the end of the day, it's become very, very simple. So there's a formula that I think I need to be giving you, the formulas also, so that it will become simple when you are doing your calculation. So I wanted to explain to you what they mean by the change in momentum. So don't be shaken because somebody's talking about the change in momentum. So by now, I expect you guys that you've begun to understand momentum. The momentum of an object is the product of the mass and its velocity. So it's just going to multiply. But when you talk about the change in momentum, it simply means there was a change in velocity. From where? From the constant velocity that you started with initially. Then there is the final velocity. So you're going to find that they'll be putting those, for example, when they put V, then they put a small letter I in small letter. That small letter I is your initial velocity. So by initial velocity, we are talking about the velocity that you started with, originally. Then later they will put maybe VF. You see there is a letter V and a small letter F. That is the final velocity. So it simply means there is some differences there. It's not the same. So take note of the difference between the initial and the final. So that's what we call the change in momentum. And in the next topic, we shall be looking into Newton's laws. I think by now you must begin to understand Sir Isaac Newton came up with the first Newton law, the second Newton law, the third Newton law. So you're going to look into the application of Newton, second law. So the one that you need to begin to understand is second law. How do we express it in terms of momentum? Yes, I'll explain to you Newton's first law, which tell you how objects, you see, when they are at peace, they are resting, they will continue in that uniform, wherever they are, unless you apply the force to disturb them, this and that. You're going to explain all those stuff at a later stage. But for now, I just wanted you to learn what we call the change in momentum. Please, guys, subscribe to my channel, like my videos, and in case they put an advert, please don't skip the advert, watch them. And that's how you can support. But the first support that I'm asking is for you to subscribe. Make sure you go check just below the video there is something called subscribe. Just go there, and if you don't want to miss any video, then make sure that on notification also you receive all notification when I post a video, and I'll appreciate. So for now, thank you. We shall continue.